Grade 8 students, so today we'll start a new chapter, chapter 11, Mechanical Waves. It is found in page 105 in your book. Waves come in many shapes and forms. While all waves share some basic characteristic properties and behaviors, some waves can be distinguished from others based on what? Based on some observable characteristics. In our daily life, we encounter mechanical waves, such as sea or water waves, sound waves, pendulum waves, earthquake waves, air waves, spring and rock waves, etc. So the objectives for today are: what is a wave, definition of a mechanical waves, types of a wave, transverse waves and longitudinal waves, periodic waves, characteristics of a wave. What is a wave? A wave is a perturbation or disorder that propagates in a medium. A wave transports تنقل لإنرجي without a transport of matter. Okay? A mechanical wave has a speed of propagation. Speed equal distance over time. In a transparent and a homogeneous medium, a wave propagates with a constant speed. So this is the definition of a mechanical wave. Mechanical waves are waves which propagate through a material medium, solid, liquid or gas, at a wave speed which depends on the properties of that medium, such as sound, water, air, rope, earthquake and tsunami. There are two basic types of a wave motion for mechanical waves. So first one is transverse wave. These waves are waves that vibrate the particles of the medium perpendicularly to the direction of propagation of the wave, such as waves on water surface. Definition of longitudinal wave. Longitudinal waves are waves that vibrate the particles of the medium parallel to the direction of propagation of the waves, such as. So the girl in this figure is carrying a long spring. Imagine that the girl is stretching it horizontally by fixing one end to a wall and hold the other end by her hand, producing a vibration in the spring by tapping it by the hand. The perturbation propagates horizontally along the spring. So producing a vibration in the spring by tapping it by the hand, the perturbation propagates horizontally. So the perturbation propagates horizontally along the spring. So the direction of the wave is horizontal, and the direction of vibration of the loops is what? Is vertical. This wave vibrates the particles of the loop, these are loops, perpendicularly, okay, to the direction of propagation of the wave. So this wave is a transverse wave. Why? Because it vibrates the particles of the wave perpendicularly to the direction of the propagation of this wave. For an example to the transverse wave, we have sea waves. The wave is transverse wave. Sea wave is a transverse waves. Why? Because it vibrates the particles of the water perpendicularly to the direction of propagation of water. Okay. A longitudinal wave. قلنا example للongitudinal wave هن شو؟ sound waves. In sound wave, the wave is longitudinal because what? Because it vibrates particles of air parallel to the direction of propagation of water. Okay. A sound wave traveling through air is an example of a longitudinal wave. As a sound wave moves from the lips of a speaker to the ear of a listener, The particles of air vibrate back and forth in the same direction and the opposite direction of energy transport. Here, this girl in this figure, she is keeping the spring in a horizontal position as you are seeing. Here we have some loops. Okay. Here we have some loops that are under compression. When we can compress a few loops, these are loops, together and then release them suddenly, the loops vibrates horizontally. So the loops vibrates horizontally. يعني direction of propagation of this wave is what? Is horizontally. The direction of vibration of these loops are also horizontally because they are compressing forward and backward. So this wave vibrates the particles of the loop parallel to the direction of propagation of the wave. So this is the amplitude, this is called crest and trough, minimum. This is the wavelength, distance between trough and trough, or crest and crest. The speed, it is the ratio of the distance covered by the wave to the time needed to cover this distance, measured in meter per second. Type. So the speed is equal to the distance over time. If we want to find the time, so it is the distance over the velocity. The distance also it is velocity multiplied by the time, where v it is the speed, meter per second, distance measured in meter, time measured in second. The frequency, it is the number of cycles in 1 second. It is expressed in hertz in as a unit. So the frequency it is 1 over t اللي هي البيريد، والبيريد equals 1 over f اللي هي f. f هي frequency measured in hertz، والt هي period measured in. The wavelength, it is the distance between two consecutive crests or two consecutive troughs. It is expressed in meters in as a unit. So this is the symbol of wavelength, lambda, equals to v, velocity times period اللي هي t. Also, velocity equal lambda over t. T equals lambda over v. So in this video, I will briefly discuss a periodic wave. The first thing you need to recognize that transverse wave is generated by a vibration, and in this case the vibration is traveling up and down. You know that the vibration of a particle is actually perpendicular to the direction of the wave that is going out of the window, and each particle do exactly. So in this video I will briefly discuss a periodic wave. The first thing in this case to the direction of the wave, which is horizontal. If you look to each of the green dots, I can slow it down for you to make it easier. You can clearly see that each particle is simply vibrating perpendicular to the direction. Now if I paused the wave, you can notice a couple of things. First of all, there is an amplitude. The amplitude is simply the maximum height that the wave has. In this case, it is measured from the top of the crest to the equilibrium line. Of course, the amplitude can also be measured from the equilibrium line down to the bottom of the trough, but as long as the wave is moving, the amplitude will remain the same. The second thing that we can measure is the distance. You notice that the cycle is represented by the distance from crest to crest, and we call this distance the wavelength. And we can measure the wavelength also from trough. We can measure it from trough to trough. Now, what else we can measure here? You clearly see this piston at the left vibrates. You can see the piston at the left vibrates. And there is two aspects I can measure. I can either measure how long it takes to complete one cycle or one vibration, and this is called the period. But the other one I can measure is by referring to the frequency. The frequency is how much this wave. If we increase the frequency like this, you can clearly see that the vibration increases. According to the time, it is also can be determined in terms to its period. The period and frequency are reciprocals of each other. As you notice, when I increase the frequency and decrease the frequency, the wavelength changes as well. The wavelength increases if I decrease the frequency, and if I increase the frequency like this, clearly the wavelength decreases. That means that they are inversely proportional to each other. As one increases, the other decreases. If you want to know something that doesn't change, it is the speed. The speed remains constant if we increase the frequency or decrease the frequency. The speed of the wave that moves out from the window remains the same. And this because the product of the frequency and the wavelength is equal to the velocity of the wave. V equals F times lambda, and it is often referred to the wave equation, and it is one of the most important formulas in understanding waves. So the speed remains constant if you increase the frequency or decrease the wavelength, and the speed remains the same. If I change the amplitude, of course, the peak gets smaller, but neither the frequency nor the lambda, the wavelength, nor the speed changes. So how can I change the speed of the wave? To change the speed of the wave, you speed remains the same. If I change the amplitude, of course, the peak gets smaller, but neither the frequency nor the lambda, the wavelength, nor the speed changes. So how can I change the speed of the wave? To change the speed of the wave, So in this video I will repeat it. So how can you should change the material or the medium propagating the wave.
فيها صوت وفيها